Okay, dear students, welcome to the physics class. In last class, we have discussed about units, numerical value, and with example. Okay, so today we are to discuss about characteristics of units. See that unit should be easily accessible and reproducible. Second one is stable with change in place, time and physical conditions. Stable ಆಗಿರಬೇಕು. Well defined. That unit should be well defined. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಲ್ಲ? ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ ವೈಡ್ಲಿ ಅಕ್ಸೆಪ್ಟೇಬಲ್. ಎಲ್ಲರೂ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡೋ ಹಂಗೆ ಯೂನಿಟ್ ಇರಬೇಕು. ಆಫ್ ಸೈಜ್ ಕನ್ವೀನಿಯಂಟ್ ಫಾರ್ ಮೆಜರ್ಮೆಂಟ್. ಓಕೆ, ನಾವು ಅಳತೆ ಮಾಡುವಂಥ ಯೂನಿಟಿದ ಸೈಜು ಕನ್ವೀನಿಯಂಟ್ ಇರಬೇಕು ಅಳತೆ ಮಾಡಲಿಕ್ಕೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಆಫ್ ಯೂನಿಟ್ಸ್. ಅರ್ಥ ಆಯ್ತಲ್ಲ ನೋಡಿ. ಓಕೆ, ನೋಟ್ ಡೌನ್ ದೀಸ್ ಪಾಯಿಂಟ್ಸ್. ನೆಕ್ಸ್ಟ್, fundamental units. Units of fundamental physical quantity which can be defined independently are called fundamental units. ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿಗಳನ್ನು ಅಳಿಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡುವಂಥ ಯೂನಿಟ್ಸ್ ಫಂಡಮೆಂಟಲ್ ಯೂನಿಟ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಮೀಟರ್, ಕಿಲೋಗ್ರಾಮ್, ಸೆಕೆಂಡ್, ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್, ಆಂಪಿಯರ್, ಓಕೆ, ಮೋಲ್, ಇವೆಲ್ಲ ಫಂಡಮೆಂಟಲ್ ಯೂನಿಟ್ಸ್. ಸೊ ಡಿರೈವ್ಡ್ ಯೂನಿಟ್ಸ್, ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡುವಂಥ ಯೂನಿಟ್ಸು ಡಿರೈವ್ಡ್ ಯೂನಿಟ್ಸು. ಹಾಗಾದರೆ ಡಿರೈವ್ಡ್ ಯೂನಿಟ್ಸ್ ಅಂದರೆ ಯೂನಿಟ್ಸ್ ಆಫ್ ಡಿರೈವ್ಡ್ ಫಿಸಿಕಲ್ quantities which can be derived in terms of fundamental units are called derived units. ಈಗಾಗಲೇ ನೀವು ಡಿರೈವ್ಡ್ ಯೂನಿಟ್ಸು ನೋಡಿದ್ದೀರಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಸ್ಪೀಡನ್ನು ಹೇಳಬೇಕಾದ್ರೆ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂತೀರಿ. ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಸೊ ಮೀಟರ್ ಈಸ್ fundamental unit, second is also fundamental unit. So the unit of speed is derived from these two fundamental units, so that is meter per second. So there are number of examples given in this. Newton ಎತ್ತರದ ಯೂನಿಟ್ ಇದು ಫೋರ್ಸ್. ಜೋಲ್ ಎತ್ತರದ ಯೂನಿಟ್ ಇದು ವರ್ಕ್ ಆರ್ ಎನರ್ಜಿ. ಅದೇ ರೀತಿ ಪಾಸ್ಕಲ್ ಪ್ರೆಷರ್ದು ಯೂನಿಟು. ಕೆ ಜಿ ಪರ್ ಕ್ಯೂಬಿಕ್ ಮೀಟರ್ ಆರ್ ಕೆ ಜಿ ಪರ್ ಮೀಟರ್ ಕ್ಯೂಬ್, ಇದು ಡೆನ್ಸಿಟಿಯನ್ನು ಹೇಳುವಂತಹ ಯೂನಿಟು. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ದ ಸಮ್ ಎಕ್ಸಾಂಪಲ್ಸ್. ಸೊ ನಾವು ಕಮ್ ಟು ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ಸ್. ವಾಟ್ ಇಸ್ ದ ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ಸ್? A complete set of base or fundamental units is called system of units. See, commonly we are using number of units for the measurement of length. For example, if you want to measure the length of room, we are expressing and in terms of feet, means we are using feet scale. So if you want to measure the length of, see, if you want to measure the length of pen or pencil, we are expressed in terms of centimeter. Similarly, if you want to measure the distance between two places, we are expressing in terms of kilometer. See, in all cases, we are measuring length only, but we are expressing that length in feet, in centimeter, in meter, kilometer, inch, millimeter, etc. So, here there are three system of units commonly used for the measurement of physical quantities. One is CGS system. In this system, length is measured in terms of centimeter, mass is in terms of gram, and time is in terms of second. If you choose this set, means we are measuring in CGS system. Suppose if you want to express the units in terms of FES system, means you have to measure the length, or you have to express the length in terms of feet. Next, mass is in terms of pound, time is second. Similarly, MKS system means length is expressed in terms of meter, mass kilogram, and time second. See, for these three systems, time is measured in all three systems second only. Second is the common unit of time in all systems, but length and mass having different units. Okay. Next one, FES system. What is the inconvenient of FES system? See, if you want to measure the length or distance in FES system, it becomes very difficult. For example, if you want to measure the length of the rod in FES system, we are measuring, or we are using foot as well as inch. If you want to express foot to inch, so what happens? You have to multiply with 12, because 12 inch means 1 feet. 1 foot equal to 12 inch. Next, yard. 1 yard means 3 feet. Okay. Next, chain. 1 chain means 4 rods, or 22 yards, or 66 feet. Next one is furlong, means 10 chain, means 660 feet. 1 mile means 8 furlong, or 80 chain, 5280 feet. Okay. See, the difficulty of this system. In all cases, we are measuring length only, but having different units. Okay. Inch, foot, yard, chain, furlong, mile, etc. Okay. Now come to the example for derived unit. See, here an object is given, its length is 10 centimeter, breadth is 4 centimeter, and height is 5 centimeter. So all are in centimeter. If you want to measure the value, means length into breadth into height, LBH. So 5 into 4 into 10 will get 200. Centimeter into centimeter into centimeter, centimeter cube, or cubic centimeter. So this cubic centimeter is derived unit. Clear? Okay. See, for the measurement of volume, okay, volume is the amount of space occupied by solid, liquid or gaseous. Simply we are measuring volume means how much space required or occupied by that object. Cleared? So there are several instruments used for the measurement of volume. See, cylindrical flask is there, syringe is there, burette, pipette, volumetric flask. Cleared? So these are the instruments for the measurement of volume. Next, this one is not necessary, just for information only. Teaspoon, half teaspoon, like that. So now come to the SI system of units. See what happens in three systems. The inconvenient of these three systems, that is FES system, MKS system, CGS system, it becomes very difficult to understand or to convert from one system to another system. And because of these difficulties, especially in physics, because we are measuring everything, even very small object also. For example, the wavelength of light is very small, and it is very difficult to express wavelength of light in terms of inch or FES system. And we are measuring even distance between moon and earth. Okay, so to avoid all these things, commonly this international system for the measurement of physical quantities, okay, so that one is SI system. So in SI system, it is extended part of MKS system. Okay, see here there are 7 fundamental quantities or base quantities along with their name and symbol. So here length is measured in terms of meter, and the symbol is small m. Next, mass is kilogram, you have to write kg. Time is second, S is the symbol. Electric current, ampere. Temperature, Kelvin, K. Luminous intensity, candela, CD. Amount of substance, mole, MOL. So these are the 7 base quantities or fundamental quantities in SI system. And remember all these 7 fundamental quantities along with their units. Cleared? So note down the definitions of meter. 1 meter means the length of the path traveled by the light in a vacuum during the time interval of 1/299792458 of a second, or 1/3 into 10 raised to 8, you can say. So in that short interval of time, okay, so the distance covered by the light itself is the 1 meter, because in 1 second the distance covered or the distance traveled by the light is 3 into 10 raised to 8 meter merely. The exact one is 299,792,458. Okay, so similarly kilogram, see, kilogram is the one standard weight. See, the mass of international prototype of kilogram, it is made up of platinum iridium alloy cylinder kept at International Bureau of Weights and Measure. Okay, so its mass is equal to 1 kg. Similarly second. Okay, so only you have to remember these three fundamental units for exam purpose. Okay, meter, kilogram and second. That much enough. Okay, no need of this ampere, Kelvin, just for information it is. Okay, even this mole definition also important, and commonly it is used in chemistry, because the quantity of substances especially expressed in terms of mole. Okay, so the mole is the amount of substance of a system which contains as many elementary entities at there are atoms in 12 gram of carbon or 0.012 kg of carbon. Okay, so these are the some important definitions of the base units. Okay, so this one is the candela. So in next class we have to discuss the remaining part of this units and measurements. Okay, thank you.